Okay, we've gotten a few comments about how I put together the layout and putting in the risers and laying the basic foundation for the track for the roadbed. So today I'm going to step back a little bit and talk about how the risers go in, because some of this goes to how you actually actualize your layout plan. One of the temptations is you build a plan for a layout. You may use an automated system like I did. You get very obsessed about dimensions and where everything goes. And that's good up to a point when it comes to planning, but when it actually comes down to building the layout, you're going as much as by visual effect. And for that reason, you always have to be prepared to make adjustments and allowances. And that's basically what I've been doing here. Because now I'm down here in the layout room and seeing where the track is going. I'm seeing the elevations and I'm making adjustments, saying, hey, this will work well, this will be good, this will make a good statement. And what I'm going to doing here is I'm actually putting in the turn back curve where the line goes into more mountainous territory and the branch line rises above it. And when I put in this curve, as I said before, I'm using the natural curve of the spline here, using this 8-foot piece of masonite that I'll use on building the roadbed, because it does develop a nice spline curve when you bend it. And I'm putting in these various risers, and in a moment I'll reposition the camera and I'll show exactly how I put the riser in and how I put the cleat in. But the important thing to understand is the riser gives us the elevation. That's what we measure the grade on. Now, you want the riser to be as vertical as possible and straight as possible, but the actual rise in elevation is what's important. As far as leveling side to side to make sure everything is level, that's what you're going to do when you position the cleat. And I'll get into that when I show that portion of it. But right now, as far as positioning the risers, these are what really go to the radius of the curve, establish the radius. And I'm setting that radius up by taking these pieces of masonite strips, bending them around to the risers, getting a curve that I'm satisfied with, again, the aesthetic appearance of the curve, and then marking on the joist where the edge of this strip of masonite is. Now, that's not the center line of the curve. That will actually be the edge of the riser. Okay, and the risers are being positioned. You'll see this later when I get to this portion of the construction. I'll move the video in where you can see it more closely, and that's what determines where I position the riser, the inner edge of it. So with that, I'm going to reposition the camera, and then I'm going to show more detail how I actually put in the risers and the cleats and how everything gets leveled gradually as you go through that process. Okay, so here we are. I'm getting ready to install this next riser right here. And I have my level here sitting on the prior two risers, and this is showing that it's in a slight upgrade of about 1/2%. Now remember, because this is a curve, that is a compensated grade, so the actual grade is probably somewhere around 0.4%, 4.5 tenths. Right here it says it's 1/2%. And what I want to do is I want to carry a level line, or close to it, from here to this riser. In other words, I want to take the grade out. It's a very minor grade. I want to take the grade out, and this is going to be somewhat of a high point, and as the track goes further on around into the secondary town, it will descend slightly. And this brings up a good point. There's very seldom anything that is really level track. Okay, track always slightly follows contours. Even the most level track has some minor percentage of grade ascending or descending to it. And this gets to a very key point. Railroads, because they really, in mainline traffic, anything over about 2.5% is considered an unacceptable grade, because the efficiency of rail is steel wheels rolling on steel rails, and that's fine, but when it comes to grades, traction becomes an issue. The coefficient of friction is lower. So they try to keep their mainline grades fairly gentle. Branch lines are a little different. They can afford to be built to a somewhat steeper gradient if necessary. But to do that, railroads will make all kinds of concessions. They will tend to go around obstacles as opposed to going through them. They like to follow river courses a lot of times, near rivers, because they generally give them a chance to keep a fairly gentle grade. And because of that, there's very seldom any really truly straight tangents of any great length on railroads. The longest tangent on railroads in the world, I believe, is in the Nullarbor in Australia, which is quite a lengthy tangent, but that's the exception, not the rule. Even in the great U.S. Midwest, where we tend to think of ground as level and a lot of straightaways, there's not as much as you might think. And in addition, as you move from the Mississippi River to the Rocky Mountains, the overall elevation gains between 4 and 5,000 feet. So you're gradually going up grade. So they're still trying to work their way around the obstacles, and there's a lot of gentle curvature. And for this reason, they don't like to go through obstacles because tunneling is very expensive. They'll much more elect to deflect an alignment somewhat to get around and maybe have to do cut and fill. But that's cheap. That's cheaper than building a tunnel. They'd rather not do that, but they try to make all these compromises. So, with that in mind, I'm mimicking railroad behavior here. This is a slight upgrade, but now I want this to be level here. So what I'm doing is I'm going to take, first of all, right here, you might be able to see it, there's the pencil mark that I told you about where I drew using the spline to get the alignment for the curve. And there's a pencil line here, and I'm going to take this riser and line it up to it, the edge here with that pencil line. And then I'm going to take my heavy duty clamps, and by the way, these clamps are really good. I get them at Harbor Freight. They're very inexpensive, they come in very handy. I've probably got 3 dozen of them of various sizes, and they're very good for holding stuff like this. And I'm going to clamp this riser where I want it, okay, and drop one of my screws there, and then I'm going to take this level that I've got set on the long beam, and I want to elevate it to the point where I have very close to, if not an exact 0% gradient between these. Now it's showing it's still going slight upgrade, and I'm working its way down, very, very slightly adjusting it. Let it settle out. It takes a while for this level to re-level. It says they're 0.3% up, so I'm going to drop it down just a little bit, let it resettle itself. Okay, now we have a level grade. Now, this is holding this temporarily in this position, but I want to be able to fasten it down. So I'm going to take this C-clamp, move this out of the way, and tighten this down to hold this riser exactly where I want it. Okay, preparatory to screwing it down. Now, before I forget, one thing I'll tell you here is the risers themselves. I cut a lot of these on my radial arm saw to various lengths. You see this is a 5-foot riser, or 5-inch riser. Here's a 7.5 inch, 6.5 inch. They're all marked. I measure them out, and I keep them handy because you're going to have to keep pulling up different lengths of risers, and you don't want to waste too much length in your materials, so you want to try to find one that's closest to where you want to be. Now, I notice this is settled out here at 0.3%, but that, for all intents and purposes, that's going to be level, okay? Because the percentage changed when I clamped this down. All right, if I loosen this clamp, you'd see it's settled back a little bit. This is a very, very sensitive level, digital reading level. Now, I'm taking this clamp off. It's being held by the C-clamp now. And I'm going to get one of these, get out of the bag, 1¼ inch self-drilling screw, okay? If you look closely at this screw, you'll see at the very front of it, there's actually a drill bit made into it. And this is very handy when you're doing this kind of thing, because you don't have to keep drilling holes to insert screws. It's also got a modified pan head, so it's a quite wide head to almost act like a washer against a surface. They're really good for this kind of work. I'm going to take my little Ryobi drill here, drill screwdriver, move this out of the way, and then just near the bottom of this, I'll do it near the top here, that'll be a little better. I'm going to put this screw in, just one for right now, and I'll explain why. Screw is going in. Okay, you can see it tighten. Now, what I'm going to do is say, wait a minute, what about side-to-side level? Well, again, ultimately, that's going to be the riser that's going to set that. But you want to try to get these, or the cleat that's going to establish that, but you want to try to get these risers as close as you can to being level on the top level surface. And that's where this comes in handy. This is a post level, handy little device. I think it was $6, Amazon. You can see it's got a level here and a level here and a level here, so you can establish level in both directions on the post. Use them for putting in fence posts. And what I want to do is try to get this bubble, showing my side to side how vertical it is, to line up between the lines. And it looks like I've got it just about on. And the reason I only have one screw in there is it's just easy to turn it to position it. So I'll put this in like this, and it looks like it's got it. I'll set my level aside for the moment. Come back here and do extra clamping just to be sure so this thing stays in place. Set my clamp around an area where it's good to work around. Okay, I got that. And this, whereas I used a 1 1/4 inch before, 1 1/4 inch, I'm now going to use a 1 1/2 because I really want to hold it. The 1 1/4 holds it, but not permanent. This just one wouldn't work. And for that, I'm going to use my heavier Ryobi. This is a right angle drill. Very handy little gizmo. Got that a number of years ago. I'm going to start this screw. That's in. That riser is attached. It isn't coming loose. And the next thing we're going to do is we're going to put the cleat on this riser, and I'll show you how we get level on that. But before we do, let's see what we did. 1/10 of 1%. Okay, minor 1/10 of 1% upgrade. For all intents and purposes, because it's compensated, that's level. That's the summit of this slight rise through here. And I'll put another one in level here, and then I'll start bringing it down grade as we go further around into the town. So with that, I'm going to shut the camera off for a minute. I'm going to get a riser ready, or a cleat ready to put on, and show you how we do that. Okay, so the next step is we're going to mount the cleat to this riser. Now, I'm not put in a lot of the cleats yet, but I'm doing this to just show how I'm doing it. And the cleat is made of about a 1 1/2, 1 3/4 inch piece of the same stock that I made the risers from. And by the way, I ripped the risers on my table saw from a much wider sheet of very good, clear lumber. So I have no problem with knots or any defects or checking or warping or anything. So it was a little more expensive lumber, but it makes very good material. And this is about, as I said, about 1 1/4, 1 1/2, 1 3/4 inches long. And a couple of things I did here. You can see on here that I marked the center line. This is the center line of this face, and here, and there's a hole drilled clear through on the top, on the center line. And the reason I did that is I mentioned these cotter pins. My grandfather had thousands and thousands of cotter pins, and I found a drawer full of, it must be 1,000 of these. And I'm going to use these to align the spline when I do the spline roadbed. And they slip right in this hole right here, and this I'm going to leave it when I put the first side of the spline on, and later on you'll see how that works. But right now what I want to do is attach this cleat to the riser. And how I'm going to do this, and again this is critical for the leveling. What I'm going to do is I'm going to take some liquid nails. And liquid nails will bond pretty much anything. It's your go-to adhesive for anything. And I'm just going to put a little bit on the back here. Okay, and there's a reason why I'm doing this. You can see it's just spread. You can put a little dab of it there. Okay, we'll get some down there. There we go. Okay, now it's the liquid nails that's actually going to hold this exactly in position. Now I'm taking this cleat and I'm putting it up against the riser and centering it by that center line on the center of the riser, and then I'm going to take my C-clamp, my trusty C-clamp, open it up just a tad, get it open here, and then use it to clamp this to the riser. The reason I'm doing that is I'm going to put a screw, again one of those self-drilling screws, through the riser into the cleat. But the screw is not really what's going to hold it permanently, it's the liquid nails. And taking the screw here, using a 1 1/2 inch and my Ryobi screwdriver. Drill this in. Okay, that's drilled in there. Now, what I'm doing, release the clamp. Now, I take my digital level, and you can't see the face of it here. I'm going to turn it on, turn on the power, and it's reading out. Okay, now it's in degrees, now it's in inch per feet, now it's in percent. And what I want to do is I want to set it here, and I want to be able to turn this cleat in such a way that I will get it at 0% side to side. And there I've got it. Okay, that right now, and you can see, I'll turn the level here. I don't know if you can see the on it, but when I'm looking at it like this, it's reading 0%. Just give it one, let it settle out there a second. Okay, trust me, it's reading now 0%. I'll move the camera around so you can see it. You can see the display on the level there, and I'll zoom in on it. And you can see it's reading 0%. So now I know that I've got a level side to side, and I've got my gradient established. And this cleat, when this liquid nail sets up, will be permanently fixed at that point. I won't disturb it for about 24 hours, give it time to set up. Again, the purpose of the screw is just to give me a way to hold this while I adjust it and hold it there while the liquid nail sets up. And then once that happens, I'll come back and I'll put the cotter pin in here, and then it'll be ready to put the spline roadbed up against that and start actually building my sub roadbed. So that's how we put in cleats, risers, achieve grade, and make sure everything is nice and level. Okay, it's the next day, and I've finished installing all of the risers that go from the east end of the staging yard over to the mountain town in the middle for both the branch line and the main line. And I've also finished putting all the cleats on them, and now I'm going to wait overnight for the adhesive, the liquid nails to set up. I want to make sure it gets a good bond to hold the cleats in exactly the right position to the risers, and I've made sure they're all leveled so everything is good, leveled to within 1/10 of 1 degree, which is for all intents and purposes level. And then I'm going to come down and set the cotter pins and start building the masonite roadbed, the laminated spline roadbed. And I'll step aside from the camera here for a minute and pan around, and you'll be able to see how these risers have all been set up. And you can see everything is set up and ready to go. So it won't be too long before I actually start putting down roadbed, and or sub roadbed, and once I start doing that, I'll be putting down cork roadbed on it. I'll show you how you do that. And then it'll be a matter of laying track and running trains at least partially around the layout, at least to about halfway. So with that, I'm going to shut down for today and pick up tomorrow with building laminated spline roadbed. I'll show you how that's done. Okay, you can see that I've been busy. I've been putting in spline roadbed, and this has been interesting. This is the first experience of actually building with spline roadbed. I know all about it, I read about it, studied it, but actually large-scale building with it, this is the first time I've done it. And I have to say that I'm very happy with the results. You can see even this small portion that we're looking at right here. This is the main line that goes from the east end of the staging yard and reaches around to the town in the middle of the layout, which is actually right behind the camera where it's situated right now, which I haven't done any work on yet. But you can see already that the spline roadbed gives a very realistic shape to the roadbed, to the alignment of the track. It doesn't look like a toy train set. It looks like the way we really lay track. The curves are nice and sweeping. They have spiral easements leading into them. Very realistic. So what we got right here is 4 parallel strips, or 8 parallel strips, excuse me, of 3/16 inch or masonite, stood on edge and laminated, and using good old liquid nails to glue it together. And they've been secured to the risers in this section. Now this area right here, this is the branch line reaching up to the lumber mill off layout, but this I haven't put the spline roadbed in yet, but this will be rising above the main line. This will all be mountainous scenery in here, which I'm really looking forward to getting to work on. And this is laid down 1 strip at a time, and in another segment that I'll probably do tomorrow, I'll show you exactly how I build that. Build it up, because there's some tricks to that. But this will support the roadbed. This is the sub-roadbed. This will support the roadbed for the layout. Now the actual roadbed is cork, and it comes in strips like this, and you'll be able to see right here, to show you up close, that the strip is actually cut on a bevel in the middle. Okay, and when you get the strips, they're together like this, and what you do is you have to separate it like this. Just fold it, and then fold it back, and it separates. Now those of you that are in model railroading know this is good old standard cork roadbed, but I mention this for folks that aren't familiar with it. So when it comes down to putting it on the layout, this cork roadbed will be glued using good old DAP adhesive caulk. You can get it in a tube like this, which I use for small areas working with it, or you can get it in canisters, 10-ounce canisters for use in a caulking gun. It's cheaper per ounce that way. And adhesive caulk, and it gives a good bond, not an absolutely unbreakable permanent bond, but a perfectly good bond for the roadbed on the sub-roadbed. And that will be used to cement this cork roadbed. Now you'll notice here that the cork roadbed is actually a little bit wider than the sub-roadbed. That's okay, because the sub-roadbed is more than wide enough to support the actual weight of the track, and it's very, very sturdy. These eight plies of masonite laminated together, tempered hardboard, are quite strong and quite inflexible. And so when this is glued on top of here, the track will be placed on this, and the reason I do this is it provides spacing to run wiring down. Scenery will come up to this, and I will space this out with scenery, but that will all be invisible when the layout is done. You won't see that. It'll just be the scenery running up to the track, to the profile of the roadbed, which gives a nice sloped profile to the edge of the track. So this is where I'm working on it. It's a gradual work, starting from one end and putting in a central strip, and then building out from that. And in the next segment, I will show you exactly how we build up those layers of spline roadbed to create the completed roadbed that you see right here. Well, now we're at the other end of the line going into the small town. The small town will be located right over here, and the line that you saw in the previous clip coming from the east end of the staging yard is coming around this way, and I'm ready to start building up the spline roadbed. Now, one of the things I've learned in building this and using the cotter pins is that it is always easiest to work from your curves and to work from the outside of the curve, because I'm using the cotter pins to describe the center line, and it's easier to bend and hold with clamps the first course of roadbed on the outer side of the curve, because you're bending it convexly, okay, or concavely, and so it's easier to start with the outside of a curve and then build inward and align your track that way. This curve coming in here is on the opposite side, so it's going to dovetail coming in here. I'm going to build out, and it sweeps around this area and then comes down into this area here where I've laid in a piece of masonite to help get my alignment on this. So what I'm going to do now is take mastic adhesive and glue it the inner portion of the inside of the curve of the roadbed, which has already been down, to the outside portion I just put in, and then I'm also going to glue this outside portion to the inside portion on the reverse curve that heads down into the town. So with that, let me get my mastic, my liquid nails, and I will glue this up. Okay, what you see here is I've got my liquid nails in the caulking gun, and I've cut a very small bevel in front. It's oozing out there on me a little bit. Very small bevel in front. I don't want a lot coming out. And I've punctured the seal, and see just a little bit of pressure is behind it, so it's starting to come out of there. And here is the outer portion of the outside of this wide sweeping curve I showed you, and this is the inner portion I'm going to glue up to it. So what I do at this point, notice I've got them both clamped right here to this cotter pin. Okay, and this is the cotter pin keeping everything centered. Now I brought this section of the outside of the curve just up to the cotter pin, because I want to be able to lay it up flat against this other section here. So what I'm going to do is I'm going to take my liquid nails and run just a little bit along here. Just want to get it on there so I get some adhesion, and then back off the pressure on the canister, set my gun down where it won't fall on anything, and then bring these two pieces together and clamp them so that they're firmly clamped together and to the cotter pin for the alignment. You can see the liquid nails is oozing out of the top there. And you're going to find some unevenness between the various layers here, and we'll have to rough that out with a sure form shaper to basically level things up. But we won't do that till we put the track in. Now I'm going to get another clamp here just to be sure, and I'm going to clamp this. Okay. Now in working with liquid nails, you want to be sure that you give it time to set up, and it says it sets up rapidly, but I found that I work this in stages. One of the reasons it takes a while is I'll do a bunch of courses and then I'll just let it set up overnight, and that's a wise thing to do. So this is how we actually glue it together. Now what I'm going to do is I'm going to move the camera over this way around here, and see, here's the other portion. This is the other end of that piece of the outside of the curve that I just glued in, and now we've got a portion of the curve that goes the other direction, the reverse curve into the town. So I want to glue that also to make sure everything stays aligned here. I've got it the way I want it. And I get a clamp ready, and I'll do another small dabs along here, just you don't need much. Because you notice these various products, liquid nails, the trade name liquid nails tends to be more fluid than the PL510 that I was using, okay, by DAP. That's just something you have to deal with. So liquid nails, you got to be careful to take the pressure off of the caulking gun as soon as you're done squirting it, or you're going to have drools of liquid nail all over the place, and that's really not something you want. So with that, I'll bring this up together here. It's already clamped there, and I'll clamp it here to make sure it has good compression on that joint. And I'm just going to leave that overnight to make sure that lines up. Now once this sets up, I'll be able to add the other courses, because everything will be held in registration here between these central pieces. So this is how we start the spline roadbed construction. And I'll just turn the camera a little bit more. You'll see here, looking down here, you'll see this is where this white straight alignment, this piece of PVC lumber I have in here, this is designed to make sure I get a straight tangent track going in there. So this line gradually curves into that, and there'll be a turnout in about this position here for a passing track in the town. So with that, that is another part of building spline roadbed. I'll come back tomorrow and I'll add more courses to this. Well, you can see from that opening pan shot, the spline roadbed for the main line from the east end of the staging yard located over there to the western departure from the small mountain town located over here is in, all approximately 60 feet of it, 65 feet. And in addition, all the branch line spline roadbed is down. So that's all been constructed. It was a long process of laminating 8 strips of 3/8 inch or 3/16 inch masonite to form the spline roadbed. And but you want to get that right. Taking time, making sure everything was lined up properly and all the grades were in, and I was getting really what I wanted. And also, it's a nice time. You can actually see the railroad start to take shape, and you're always making minor adjustments because a curve looks a little better with a little different radius on it, or a different lead into it, and it really gets exciting because you get to see, get a picture in your mind of what the railroad is going to look like. And with that, I wanted to address a few things about building spline roadbed so I can wrap this episode up and get it posted. Just by way of administrative announcements, the next episode I plan on showing the final preparation of the spline roadbed for the sub-roadbed for the receipt of the cork roadbed. And that's a messy operation involving sanding, and I really didn't want to get into that in this episode, because you always, no matter how much care you make in lining up the top surface of these splines, there's going to be differences, and you want to make sure that you don't have an outward leaning cant on a curve, which can cause you a problem. So I've got my rotary belt sander all set up to do that, and it's just going to be a day I'm just going to have to decide to get messy down here and then do some big cleanup with the dust that it generates, and wear a respirator mask while I'm doing it. And after that's done, then I'll be gluing the cork roadbed to the spline sub-roadbed. And then the next step of that will be gluing down the track using adhesive caulk. And that's time-consuming operation, a careful operation, but there's ways to do it. And it really gets to be enjoyable because, again, you get to see things really start to look like a railroad. And then I'll be showing also, I hope, some additional techniques in as far as adding detail to the backdrop, because right now all you've seen is sky painted on the backdrop in kind of a generic western, little bit blue, a little bit hazy sky. But I've got some techniques I've been experimenting with, and I want to show that. So that'll be something to look forward to in the following episodes. But to address some things about spline roadbed, first of all, one of the things you need when you do a lot of this is a means to clamp it, because you're using, and I found that the best adhesive for it is, and this isn't a commercial, but it's made by Loctite. It's called PL510. Liquid Nails makes a product that's basically the same thing, and it's a good product. The only complaint I have about it is the Liquid Nails product is a little more liquid than the PL510. And what that means is when you've got it in your caulking gun and you've laid down a bead of it, and then you're ready to go moving, you always have to be careful to take the pressure off your caulking gun ram here, because the stuff just keeps oozing out of the tube and you'll have these puddles of adhesive around the place, whereas PL510 doesn't do that. Okay, so I like it. It's a little better to work with. So whenever I can find it, I use PL510. Just a satisfied customer endorsement, no paid announcement. One of the things you really need when you do this, when you build up these layers of masonite, is a means to clamp it, because you're going to be clamping along all these curves to make sure you get a good bond, sometimes as often as every 6 inches. So you need a lot of these kind of clamps. I buy them at Harbor Freight. I think they're made in China. They're really inexpensive. You pay like 95 cents for one of these, or you can get a whole bag full of them for about $15. And I've got, as you can see, there's clamps all over the place here. I've got a whole bunch of them in various sizes, and you need to use a lot of them. And another way to clamp is by using, when you've got just a couple or 3 thicknesses of masonite, so you don't use up your really heavy duty clamps, is the good old spring clothespins, which you can find pretty much anywhere. These work well, you just need to use more of them, but they're handy to stand in, and they'll accommodate about 3 strips of 3/16 inch masonite, another good way to clamp. And then another good expedient clamp that I found, when you got just 2, when you're running the center line of the spline, these binder clamps, these little black metal wire binder clamps you get at Home Depot. I get them online. You get box of them for $1. It's a dozen of them or something. So they're very inexpensive. And that kind of leads to a little bit of a joke about the hobby. We seem to be We do a lot of projects in model railroading, a lot of use of C-clamps. Of course, that's the other means of clamping. Here's a good old carpenter C-clamp. That leads to a running joke about the hobby that an offshoot secondary hobby is C-clamping or clamping. So you find yourself doing a lot of that, but you really need to. And once you do that, you get everything good and clamped both horizontally and vertically, so you're lining up with the tops of your cleats and risers because you are changing grade. The next thing you need to go do is give it that little bit of extra securing to the cleats on the top of the risers. Now, there's a couple ways you can do this. One of the ways I do for more stronger hold is I use number 5 1.5 inch wood screws. And I have drills that I get that actually have a countersink that you can tighten, move up and down on it, so when you drill the hole, it'll countersink for the head of the screw. And that's important because you're going to drill in there, you want the screw to sit a little bit flush inside the top of the roadbed because you're going to be sanding, and you really would rather not hit that screw with your sander. Another way to do it, which works pretty well, and it's expedient, is using number 17 1.5 inch wire brads. And what I do is I take my small drill and I drill a 5/64 inch hole, which is just the diameter to clear a number 17 brad, just down through the masonite, and just to get a start into the cleat, just a tiny little hair of a start. And then I drive the nail through the roadbed down into the cleat. Now, one of the things you need to do is to drill in the center of a piece of the masonite. And one of the things that you need to do that, which I don't have right here handy, is a drill guide punch, but you can get them. They're a spring-loaded punch. They got them at Home Depot. Again, they're just a few dollars. And basically, you push down, and it is an adjustable spring load in there that drives the point into the surface, so you've got a good dimple to start your drill in, so your drill won't dance around out of the place and put the hole in the wrong place. And then using your small tack hammer, drive the brad into the cleat. However, one thing you'll notice is because the cleat is not plywood, but it's regular grained lumber, and it's small, not very thick, is that brads, because they have a very sharp conical point on the end, can sometimes tend to split small pieces of wood. And there's a trick I learned years ago about driving brads into lumber, and that basically means taking the brad before you drive it in, and you just sit it down with the point up and just about 3 times hit it, and you're just going to put a little bit of a dulled mushroom on the end of that very sharp point. Okay, it just makes a little bit of a flattening and a kind of a mushroom shape. And then you drive that in through the hole. And what that does is instead of the point of the brad acting like a wedge and potentially splitting the wood apart across the grain, is it pushes its way through, and it doesn't split as much, or a tendency to split. So it's a little trick. I don't know, 40 or so years ago I learned it when I was first learning woodworking, when I built my first major woodworking project, which was a sewing center for Kathy. So just something to know in case anybody hadn't seen that. And then one of the last things you do is once the brad is in there, you don't want the hole, the head poking up above the hole, is I just take a screw, one of these self-drilling flush pan head screws, and essentially put it on top of the brad, like this, and just hit it a few times, and it's like a nail set. It just pushes the head about 1/8 of an inch down in there so it doesn't catch on the sander, so you're well clear of the sander. So that's a little trick. Now, another thing I want to mention here before we go on about what I'm doing with the roadbed is over here you'll notice, right in this section, you can barely see it, the roadbed for the main line, the sub-roadbed, diverges because there's going to be a passing siding in this secondary town. And this is still out in somewhat of the graded scenic portion of the layout, so I wanted to mount the turnout there. Now the turnout that's going to go in there is this number 8 left-hand code 83 turnout, an Atlas custom line code 83. And that's going to be mounted right here, okay? And I'll show you a graphic in a moment here with how we space out the spline roadbed, how you do a divergence on a spline roadbed to make this second line come off of it, and then mount the turnout to it. Now the turnout will sit right in here, and you'll see an image with the turnout a little bit sitting on this. And the turnout will be powered by a stall motor, switch motor, underneath the sub-roadbed. So I have to drill a hole right about here for the throw bar from the stall motor switch machine to move the points of the turnout. So I had to thicken the roadbed at this point, and you'll see that on the graphic. And in order to give me enough thickness so I could drill a hole through but not weaken the roadbed through this area. And basically it amounted to creating a template, which I'll again show on the graphic, and how to get this divergence that I needed for this number 8 turnout. Now for those of you that don't know much about railroading, you heard me talk about this as a number 8 turnout. In American railroad practice, turnouts, switches, we call them turnouts. In Britain they call them points. Okay, what we refer to as points are the actual movable rails at this end of the turnout. By the way, these are the points, these are the stock rails, and this is called the frog up here in American railroad parlance. But these turnouts, by American practice, are measured by the rate of divergence of the diverging line from the straight line. Okay, and this is a number 8, meaning that for every 1 unit of travel, the rails diverge or for every 8 units of travel along the line, the rails diverge by 1 unit. Okay, and it's American railroad practice that the diverging rails beginning at about this point go straight through the frog. More European railroads continue a curve through the frog. We don't. By our engineering standards, we take a straight rail through the frog on both lines. So that's why we measure our turnouts by frog number, which again is this same thing as units of divergence by units of travel. So this is number 8. It diverges 1 unit for every 8 units of travel. This is a pretty broad turnout. The curve radius in here is about 70 inches, which is really quite broad, but this is to accommodate large mainline locomotives and a fair amount of speed going through it. In reality, the same type of turnout on a real railroad is normally about a number 15 or 20, which is quite a bit narrow, smaller divergence, but that size turnout would be impractical in HO scale. But this looks very realistic for HO, and because this is a main line I'm talking about here, I'll be using a number 8 turnout. Elsewhere on the layout, I'll be using number 6s, and in some cases in industrial switching, number 4s, which are low-speed turnouts designed for basically industrial trackage switching, or number 5s. And with that, I'm going to get ready to wrap up things here and post this online. I think I've covered everything I wanted to talk about. One other thing. When it comes to track spacing, again, the National Model Railroad Association has got standards on everything. Well, one of the nice things you can do is you can go online to the NMRA website, the Recommended Practices website, and you don't have to be an NMRA member. You can download all these data sheets, and this happens to be Recommended Practice S8, which deals with track standards, track centers, specifically how far between the center lines of track for the various scales, both for tangent, straight track, and for curves. And you can look up in here and see how much your minimum standards are for separating the spacing between the tracks so that you don't have equipment colliding in here. It's done by various standards based on the size of equipment you intend to operate, and all the data is in here. This is a very handy thing, and there are pages and pages and pages of these standards on the NMRA website, freely available to anyone who wants to use them. So they're a really good resource of information. And with that, I'm going to get busy doing some final trimming here and get myself set to start making a mess, probably tomorrow, with my belt sander.